We now discuss the hexadecimal number system, famously known as hex. And under this number system, we have 16 symbols. It is said to be a radix 16 system, and these are numbers or the 10 digits of the decimal number system 0, 1, 2, all the way to 9. Then we have 6 additional characters, that is A, B, C up to F. So they are represented here, and we say that each of these hexa numbers can be represented by a decimal number and by a binary number. So here the first 7, or actually the first 9, have the same decimal equivalent. So 0 represents 0, 7 represents 7, 9 represents 9. And the same way we represent the decimal numbers in binary, the same representation is here. The only thing we are seeing here is that we consider them to have the weight of 4 binary digits instead of 3, like we did in octal number system. So the same way we represent 7 in decimal number using binary digits, the same way we represent our 7 using binary digits. But now when we move beyond 9, we realize that now we have 6 additional numbers, A, B, C, D, E, F, and we say that A is equivalent to 10, and B equivalent to 11, C 12, all the way up to F, that is equivalent to 15. Remember, in decimal we had 10 digits which run from 0 to 9. So we normally say that our maximum number is always r minus 1. Remember that, r minus 1, our r being the radix, and therefore we have 10 digits starting from 0 to r minus 1. In a similar manner, the same thing is happening here. We have radix 16, meaning that we have 16 digits running from 0 to 15. And therefore our 15 is represented by F. And the same way you'd represent a decimal 15, the same way you'd represent it, or in binary, the same way you are representing it using for hexadecimal numbers. So we say 10 is represented by 1010, which is the way you represent a decimal 10 using binary number. So I believe this is quite straightforward. You'd represent 14, which is now represented by an symbol E using the binary number that represents 14. So we want to do an example, and this example involves a whole part and a fractional part. We want to do a hexadecimal conversion from binary, and I think we had mentioned that we can, for the octal number system, we mentioned that we can group the binary numbers into groups of 3, starting from the decimal point going to the left, and starting from the decimal point going to the right. But now with the hexadecimal, we can now use 4 groups of 4. That is the major difference. With octal, we arrange them into groups of 3, but with hexa, you group them into groups of 4. And the idea is simply because we have seen that a whole set of hexadecimal digits requires at least 4 binary digits to represent either of them. So in this case, we have 2 groups, or rather 2 groups for representing the whole number, and 1 group representing the fractional part. So we have 1110. This is equivalent to 8 plus 4, 12 plus 2, 14. This is equivalent to 14, and 10 is equivalent to 2, and 111 is equivalent to 15. So because we are representing them in hexa, we just know that 14 is represented by E from our previous slide when we saw that we have 16 symbols. 2 is represented by 2 itself, and 15 is represented by F. So this is a decimal part. So we say that this binary number is represented in hexa by 2E dot F. We may be required to do hexa to decimal conversion, in which case we say that hexa number may be converted to decimal by multiplying the positional weights of 16 to the power n with the hex digit and obtaining the sum across the entire hexa number. And the best way to understand that concept is using an example. An example says that convert this hexa number to its decimal equivalent. So what we are saying in this statement is that we have the positional weights, which are base 16, and this is n. The positions are given as symbolized as n. So this is position 0, 1, 2, minus 1, minus 2. And we know our radix is 16. So this will be 16 to power 0. This will be 16 to power 1. This will be 16 to power 2. On the other hand, this is 16 to power minus 1, and the other one is 16 to power minus 2. So we are told to multiply with the hexadigit. Hexadigit in the first case is C. So we are going to do something like this. C is equals to 12, and therefore we are going to do multiply 12 by 16 to power 0. D is equivalent to 13. So we multiply 13 by 16 to power 1 because it is at position 1. And then you do 3, doesn't require any conversion. So you do 3 times 16 to power 2. And finally, we have 0.8. So we are just doing this 8 power times 16 power minus 1. And we have B, which is equals to 11 times 16 power minus 2. So we get these answers as 12, this one as 208, and this one as 768, and this one as 0.5, and this one as very big fraction 0.0429 or 43. So the final answer is you add all these and you find 12 plus 208 plus 768, and the whole numbers becomes 988 points. So we are adding 0.5 plus 0.043, and you end up with the final answer as 988.543. This is now in base 10. This is how you do the hexadecimal to decimal conversion.